Part 2 of Section 5.4. So we left off last time with Isaac having his $100 a month payments after 5 years with compounding monthly at 4.5% annual interest rate get up to $6,714.56. Well, how much did Isaac deposit? Because he didn't deposit $6,714.56. Some of that money was interest that's being earned. You got the compound interest as a driving force in the savings formula. So there's interest being earned here. So to figure out how much he actually deposited, we just need to take the payment, $100, times the N, the number of payments per year, and then times the number of years. So in this case, he did $100 a month, 12 months in a year, and he did that for 5 years. So you just multiply payment times N times T to get the amount deposited. And this ends up equaling $6,000. So he really only had to put in $6,000 when it was all said and done in order to earn that $6,714.56. So in how much interest did his money earn, rounded to the nearest cent? And for this, the amount of interest earned is just going to be the future value minus the deposit. So I'm going to go ahead and call this the D here just for the sake of writing it, the total deposits. And this will give 6,714.56 minus 6,000. And when you do that, you get $714.56. So that's the amount of interest he actually earned over those 5 years on top of what he put in. All right, so the last example here. Abby wants to have $1 million in 30 years. There's an annuity that is paying 6.5%. How much should she deposit each month? Round to the nearest cent. So for this one, let's again think about this. How much should she deposit each month? That's crucial to recognize that she's putting in more than just one amount. And that tells me that I'm looking at a savings plan formula. So as I said, it's going to be real tricky sometimes. You're going to not necessarily be able to identify maybe, am I compounding with just compound interest with one deposit, or am I, using more than one? And you got to look for those little subtle clues. And each month is the subtle clue that tells me, she's using an annuity here. There's also, in this particular problem, the keyword annuity. So that might give it away as well. But if they don't put that in there, you can still get it out of the each month. So let's see what we have. Well, she wants to have $1 million in 30 years. That's actually the future value they're giving us. They're not giving us a payment. And then T equals 30 here, time paying 6.5%. That means that R is going to be 0.065. And then each month, that's the clue that N is going to be 12 for my compoundings. So how does this work now? I want to find the payment. The payment's the unknown. So what I'm going to do is just divide both sides by all this crud that's being multiplied by the payment, and you get this F over double parenthesis 1 plus R over N to the NT minus 1 divided by R over N. It looks messy, but you can type it in Desmos looking just like this and it'll work out. But this is what you do to get the payment. You could also flip the bottom and multiply if you want, but I'm just going to work with it like this. So now, taking the pieces that we're given, I'm going to plug them in. I'm going to take this million for the future value. Put this over 1 plus 0.065. She was getting that as the rate, all over 12 monthly. And then we'll have 12 times 30 for the power there. Then minus 1. and then all over this 0.065 over 12. Just plugging in those pieces that we're given to solve for the payment. And if you go over to the Desmos, let's take a look at how this types in. We can figure this out. So let me go ahead and just get rid of this one. So I'm going to start by just putting in the million and then divided, parenthesis 1 plus 0.065 divided by 12. Get out of that denominator, close parenthesis, shift 6 to get the power, parenthesis 12 times 30. Close that parenthesis, right arrow to get out of the power, minus 1. Close parenthesis and then divide it again, and we'll have this parenthesis 0.065 divided by 12, right arrow, close parenthesis. So you can see now the answer for the payment. She needs to pay $904 a month at that interest rate in order to get to $1 million in 30 years. So that would be the answer here, $904.01. All right, so let's go back over here because I want you to realize something about interest. At 6.5%, which is a pretty healthy interest rate, very easy to earn in many mutual funds. I'm not a financial advisor. I'm not going to name any companies, but I do have some money in a company, mutual fund based company, and it's very easy to earn like 7-8% on average if you're in what's called an index fund over many years. The average with all the highs, lows, market crashes, crazy times of goodness, you can easily average 8% return over the life of the market. So 8% realistic. Let's see how that changes her payment if we get 0.08 there and 0.08 here. Just change the rate. So it went from $900 to $670. So cut $200 plus off of the monthly amount she had to put in just by finding a higher interest rate of return. A little bit more risky sometimes, but if you're leaving this in for 30 years, you got time. You can ride out the lows. And then let's go ahead and say maybe 10%, because I will say there are accounts that can get you 10% over the life of them. They are, again, a little bit more risky. You're definitely looking at long-term growth at that point. But if you put into an account 10% average per year, you now only have to put in $442 a month in order to realize $1 million in 30 years. So less than double the percentage gets you less than half the amount that you have to put in. That's something I want you to be aware of is, this power of the interest rate compounding. And this 442, some people might be able to get that. It's like, oh, I can actually do that. $900 might be prohibitive. But, if you can find a good interest earning mutual fund or other market account, you can, get to $1 million without, maybe breaking the bank every month once you start earning some money. So at any rate, I just wanted to kind of show you that because it's, an interesting thing to me seeing, how those interest rates, you really don't have to have a tremendous rate to, have a reasonable payment, so to speak. A lot of people pay that just for their car. All right, so that's pretty much the end of 5.4. And, there will be an Excel spreadsheet, that assignment that I mentioned in class that you'll be working on to get a little bit more, information or insight, I should say, into the, inner workings of some of the different loan types and things. But at this point, this is all you really need to do for the savings plan. You either plugging things in and, figuring out maybe the interest earned, or you are looking at how much needs to be paid in order to reach a goal. Those are kind of the two big aspects of the savings plan. And if you have questions about this, please ask.